Hey you guys, welcome back to another video. Today we're going to be evaluating trig functions using the unit circle. So unless you have the unit circle memorized, the hand trick is actually a method that's going to help you evaluate trig functions without having that whole unit circle memorized. As you can see, sine of theta is equal to the square root of your bottom fingers divided by 2. Cosine theta is equal to the square root of the top fingers divided by 2. And tangent theta is equal to the square root of the bottom fingers divided by the square root of the top fingers. So where are these fingers coming from? Well, if you hold up your left hand, you will see that it kind of resembles the first quadrant. So your thumb is the 90-degree angle, and your pinky is the 0-degree angle, and then we just keep going up in ascending order. So 0, 30, 45, 60, and 90. So those are the special right triangles. So remember, we have the 30, 60, 90 special right triangle, as well as the 45, 45, 90 special right triangle. So that's where those angles are coming from, and that's why they are important. Now we could measure in degrees, or we could also measure in radians. So if you remember, 0 degrees is equivalent to 0 radians or 0 pi. 30 degrees is the equivalent of pi over 6. 45 degrees is pi over 4. And 60 degrees is pi over 3. And 90 degrees is pi over 2. So the way you can remember it is that they are going in ascending order starting from the thumb. So you got 2, 3, 4, and then 6. Yes, it skips 5, but that's just, it just is what it is, okay? So just... So starting from your pinky for the degrees, you're going to go up, but then you're going to go down for the radian denominator. So 0, 30, 45, 60, 90, and then 2, 3, 4, 6, and then you end up with 0 pi. Sine we know is y, and cosine we know is x. If you have a hard time remembering which one is which, just think about it as alphabetical order. So C comes before S, meaning that the C is going to be at the top, and sine, which is like more at the bottom of the alphabet, will be your bottom fingers. So what you're going to do is fold the finger of the angle that they want you to find. So if they want you to find, for example, sine of 60 degrees, you're going to fold this finger down. Okay, so pretend it's folded right now. So sine would be the number of the fingers you have underneath this. So right here I have 1, 2, 3 fingers. That means that if this was sine of 60, I would have the square root of 3 fingers at the bottom, and it's always divided by 2. Okay, let's say they wanted you to find cosine of 60. Well, up here I only have 1 finger, so this would be the square root of 1 divided by 2. Okay, so you just count either the fingers above or below the finger that you folded down. And then for tangent, it's going to be the square root of the bottom fingers divided by the square root of the top fingers. We're going to start in quadrant 1 because quadrant 1 most resembles the hand trick. So it's going to be the easiest quadrant to work with. You don't have to deal with any positive or negative values or reference angles or anything like that. So let's just practice. So sine of 45 degrees. Your 45-degree finger is your middle finger, and then sine is bottom. So when you fold your middle finger, you see you will have 2 fingers at the bottom. So that'll be the square root of 2, and it's always divided by 2. Cosine of 0. The 0-degree finger is your pinky. If you look above your pinky, you'll see you have 4 fingers left. So that'll be the square root of 4 divided by 2. You can simplify that. Square root of 4 is 2, and 2 divided by 2 is 1. Cosine of 30, that is your ring finger. So if you fold your ring finger and you count the numbers above, because this is cosine, you will see that you have 3 fingers up there. So we have the square root of 3 divided by 2. Cosine of 90, your 90-degree finger is your thumb. Now when you fold your thumb up, do you see anything above that? No, the answer is no. There are no more fingers up there, so all you're going to do is the square root of 0 divided by 2. Well, the square root of 0 is 0, and 0 divided by 2 is 0. Okay, sine of 60. Your 60-degree finger is your pointer finger or your index finger. If you look below that, you have 3 fingers left, so you have the square root of 3 divided by 2. For sine of 0, if you fold your pinky, you'll notice that you also have no fingers below your pinky. So this is going to be the square root of 0 divided by 2, which, like we said, is 0 divided by 2, which simplifies to just 0. Now, for tangent of 90, you're going to fold your 90-degree finger, which is your thumb. Tangent is the square root of the bottom, so that's 4 fingers I have underneath there, divided by the number of fingers at the top, which I have 0 fingers above 90. Above my thumb, I have no more fingers. If I were to simplify this, I get 2 divided by 0, but we cannot have 0 in the denominator, so this ends up being undefined. Now, if you need a trick to help you remember whether something is undefined or not, just remember that 0 on the top is okay, but 0 on the bottom is a no-no. Okay? For tangent of 30, your 30-degree finger is your ring finger. Again, tangent is square root of the bottom over square root of the top. So at the bottom, I have 1 finger, so that's square root of 1. And the top, I have 3 fingers, which is square root of 3. Now, we did learn earlier that you can't have a square root at the bottom, so you do have to rationalize by multiplying the square root of 3 on the top and the bottom. So what happens is you just have to multiply these numbers. So you got the square root of 1 times 3 divided by 3 times 3. Okay, 1 times 3 is 3, and then the square root of, 3 times 3 is 9. And you can simplify this to the square root of 3, and then square root of 9 is a perfect square, which is 3. Okay, so there we have some examples on the degree side. Okay, so it's just a matter of remembering which finger corresponds to which angle. Let's try this in radians. So in radians, it's going to be the same thing. You're going to fold the finger that corresponds to the angle in radians. So remember, we started at the thumb. We got 2, and then 3, 4, 6, and then your pinky is 0. So your pi over 2 finger is your thumb. You put your thumb down. Sine is the fingers you have at the bottom. I have 4 fingers left at the bottom, so I'm going to have the square root of 4 divided by 2, which simplifies to 2 divided by 2, which is 1. Next, we have cosine of pi over 4. Pi over 4 is your middle finger. Cosine is the top. We have 2 fingers at the top, so you got the square root of 2 divided by 2. Okay. Sine of pi over 6, that would be your ring finger. Sine is number of fingers at the bottom, which I have 1 finger underneath my ring finger, which simplifies to just 1/2, because the square root of 1 is 1. Sine of pi over 3 is your pointer finger. Sine is fingers at the bottom. I have 3 fingers down there, so we got the square root of 3 divided by 2. Cosine of pi over 2 is your thumb. I have no fingers above my thumb, so I have square root of 0 over 2, which simplifies to 0 over 2, or just 0. Cosine of 0 pi. Your 0 pi finger is your pinky. Above my pinky, I have 4 fingers, so I have the square root of 4 divided by 2, which is 2 divided by 2, which is 1. And then tangent of pi over 3. Your pi over 3 finger is your pointer finger. And tangent is the square root of the bottom. I have 3 fingers below my pointer finger and 1 finger above. Okay, if I were to rationalize this, it's the same thing as if you just simplified it. The square root of 3, and then the square root of 1 is 1, and you do not need the 1 down there, so the most simplified answer would just be the square root of 3. Okay, so this is everything in the first quadrant. The first quadrant is the easiest quadrant to deal with, just because it looks like your hand, and you don't have to worry about positives or negatives. Now, going on to the next page, we're going to be evaluating in quadrants 2, 3, and 4. So it's important that you remember all students take calculus for the correct sign. So let me review that really quickly. So you have all students take calculus. All means that all of them are going to be positive. S means that only sine is positive, only tangent is positive, and only cosine is positive. Okay? That also means that the reciprocals are going to be positive there. So the reciprocal of sine, which is cosecant, is positive. The reciprocal of tangent is cotangent. That will also be positive. And the reciprocal of cosine is secant, which will also be positive. So the originals and the reciprocals are positive in their respective quadrants. Okay? Now, another thing that's important is the reference angles. The reference angle is going to be important because the hand trick only goes from 0 to 90 degrees. So you need to find the reference angle in order to use your hand trick. So how that works is we have in quadrant 1, your reference angle. The reference angle is this little red one. If you want, I can annotate it with a little r, how we did it in class. So to represent the reference angle, not to be confused with the angle they give you. Okay, so in quadrant 1, the reference angle is the angle they give you in the problem. In quadrant 2, you're going to subtract 180 minus the angle they give you. Quadrant 3, the angle they give you minus 180. And in quadrant 4, 360 minus the angle that they give you. So essentially, you're trying to figure out how close are these angles to the x-axis. Okay, so in quadrant 1, you're going to want to connect it here, which is why they're the same. Here, you want to connect to the x-axis. Basically, how close are you to the x-axis? So if you forget the formulas, just kind of try to sketch it and see how close you are to 180 or 360. Okay? So for angles in degrees, you need to find the reference angle first, and then you're going to use that angle with the hand trick. So I'm going to draw a column that I'm going to label my reference angles with, and I'm going to do this on both columns of angles. And then before I'm able to do that, I'm going to want to know what quadrants they're in so I can use the correct formula. So let's review our degrees. So here I have 0 degrees, 90 degrees, 180, 270, and a full rotation, which is 360 degrees. Okay, so 210 degrees, which is this number right here, would fall somewhere in quadrant 3. Okay. 300 degrees would be in quadrant 4. 150 would be in quadrant 2. 270 is different because notice that it lands on the y-axis. So this is the y-axis. Cosine of 225, that's in quadrant 3. 315 degrees would be in quadrant 4. 135 is in quadrant 2. 240 is in quadrant 3. 150 is in quadrant 2, and 315 is in quadrant 4. Okay, so now what you're going to want to do is use your little formulas to figure out what the reference angle is going to be. So right here, for the first one, we're in quadrant 3, so I'm going to use the formula for quadrant 3. That's going to be 210 minus 180. Okay, if I open my calculator, 210 minus 180 is 30 degrees. So my reference angle is 30. Okay, let's try the next one. Now we're in quadrant 4, so I'm going to use the formula for quadrant 4. That's 360 minus 300, that's 60 degrees. The next one, 150, we're in quadrant 2. That's 180 minus 150, which is 30 degrees. The y-axis one, we're going to do differently, so all you need to know is the coordinate point. So remember with the unit circle, your radius is 1, right? So anywhere you go, your radius is 1 if you're coming from the center to the edge of the circle. So if we're here and I'm going down to 270, I'm going down 1, and I didn't move left or right. So that means my coordinate point will be 0, -1. Okay? Because you're either going left 1, right 1, up 1, or down 1. Okay? Until the coordinate points will change. So let's say you're here and you go here. This one will be 1, 0 because you're going 1 unit to the right into the positive numbers. If you're going up 1, you didn't move left or right, but you moved up 1 unit, so it's +1 up. If you're going to the left, that would be -1, 0, and that's on the x-axis that you move to the left. And then if you go down 1, that's where you get the -1 as the y-coordinate. So we're talking about 270 degrees. We're going to use the coordinate point 0, -1. Okay. For quadrant 3, we're at 225. That's right here. 225 minus 180 is going to be 45 degrees. And we keep going. Quadrant 4, 315 will be 45 degrees. 135, that's 180 minus 135 is 45 degrees. Quadrant 3, 240 minus 180 is 60 degrees. 180 minus 150 is 30 degrees. And then 315, that's 360 minus 315 is 45. A trick that can help you remember at least some of these reference angles is that if the angle ends in a 5, such as these numbers right here, the reference angle will always be 45. Okay, so if the angle ends in 5, the reference angle is 45. You do still have to figure out the ones that are either going to be 30 or 60 degrees though. Okay, now the next step, we found the quadrant number, we found the reference angle. Now I'm going to use all students take calculus to determine whether they're positive or negative. So cosine in quadrant 3, well, we know only tangent is positive in quadrant 3, so it's going to be negative. Only cosine is positive in quadrant 4, so sine will be negative. Sine is positive in quadrant 2, so that one is good. I'm going to skip the y-axis one, going down to cosine in quadrant 3. Only tangent is positive there. Sine in quadrant 4, negative. Sine in quadrant 2 is positive. Tangent in quadrant 3 is positive. Quadrant 2, tangent, that would be negative. And tangent quadrant 4, that one is also negative. Okay, so that's basically the setup. Now that you have all of this laid out, you can start using your hand trick. So basically, you're going to use the reference angle and the function that they give you. Again, because your hand trick only goes up to 90 degrees, so you are unable to do 210. So we're going to do cosine of 30. Your 30-degree finger, which is your ring finger. Cosine is the fingers you have at the top, so I have 3 fingers, and they're always divided by 2. And now we know that it's going to be negative. Okay, the next one, we're going to do only sine of 60. Your 60-degree finger is your pointer finger. Sine is the fingers at the bottom. So we got 3 fingers down there and divided by 2. Sine of 30. Your 30-degree finger is your ring finger. I have 1 finger below that. So that's square root of 1 divided by 2, which simplifies to just 1/2. The one on the y-axis, so if you remember, we have cosine as your x and sine as your y. So if they want sine, all you need to do is give me the y-coordinate, which is -1. Okay, and then cosine of 45 would be square root of 2 divided by 2. Okay, so that's one column. Let's try another column. Sine of 45, square root of 2 divided by 2. Sine of 45 would be the same thing, but this time it's positive because we're in quadrant 2 and sine is positive there. Tangent of 60. So remember, your 60-degree finger is your pointer finger. Tangent is the square root of the bottom, which I have 3 fingers there, and then square root of the top, which I have 1. And if you simplify this, you get square root of 3 over 1, or just square root of 3. Okay, tangent of 30. Fold your ring finger. You got square root of 1 divided by square root of 3. Rationalize it. You're going to get negative. And don't forget to carry your negatives because it will be completely wrong if you don't put the negative. So you got negative square root of 3 divided by positive 3. And then tangent of 45, you got the square root of 2 divided by the square root of 2. Anything divided by itself is always 1. And then don't forget the negative. Okay, so this is in degrees. Now let's try this in radians. So the numerator is going to tell you what quadrant you're in, and then the denominator tells you which finger to fold for the hand trick. So unless you have the unit circle memorized, you're going to have a hard time trying to figure out where the radians are at. But here's a little method that will help you. If you draw just a little mini unit circle and only the x-axis on it, what you're going to do is figure out what is the denominator. Okay, and then so we have 0 here, and then when we go for positive angles, we go up. So when I go up and I make a semicircle, that'll be equal to pi. But I want to match the denominator, so in order to keep it equal to pi, the numerator and the denominator have to be the same. Okay, so again, I made this 2 to match the denominator of the angle. And so since this measurement is supposed to be pi, the 2 and the 2 will cancel, which is why I'm able to do that. Okay, now if I want to do a full rotation, so one semicircle is pi, and the whole circle would be 2 pi. So all I have to do is multiply it by 2. So over here I would have 4 pi divided by 2. Okay, so what you're trying to figure out is where would you find 3? Okay, so I have 0, 1, 2, 3, and then 4. So that means that 3 would be right in between 2 and 4. Well, right in the middle means that this would be on the y-axis. And we know the y-axis, this coordinate point is 0, -1. Okay, let's try another one. So this time the denominator is 3, so I'm going to do 3 pi over 3 on this side. And we start at 0 and we go up. And then when we come back around for the 2 pi, it would be 6 pi over 3. Okay, and I'm trying to figure out where is 4 at. So I start at 0, 1, 2, 3, 4. That means that 4 will be 1 more than 3. Because after 3 comes 4, right? So this one has to be in quadrant 3. Let's try another one. So this one, the denominator is 6. So I'm going to start at 0. I'm going to go up. I'm going to have 6 pi over 6. I'm going to go a full rotation. And this would be 12 pi over 6. And I want to figure out where is 11. Okay, well, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if this is 12, 1 right before that would be 11. Okay, so that means that we're going to be right here in quadrant 4. Okay, another one. This time the denominator is 4. So I'm going to start at 0. I go up. I have 4 pi over 4. I go all the way around, multiply it by 2. 4 times 2 is 8 pi over 4. So where would I find 3? Well, if I have 0 here, 1, 2, 3, and then 4. So that means that 3 would be in quadrant 2. Okay. And the next one does also have the denominator of 4, so I can use the same circle, and I want to figure out where 5 is going to be. So we have 0, 1, 2, 3, 4, and then after that would be 5. So that means that it's 1 more than 4, so this one is in quadrant 3. Okay. So that's how you figure that out. Let's try it again with these over here. So just start by drawing little circles with the x-axis. Oops. Okay. And then again, whatever the denominator is here, so you start at 0. This side, you're going to match 6 pi over 6 to match the denominator, and then this one will be 12 pi over 6. If this one is 4, we got 0, and then 4 pi over 4, and then times 2 would be 8 pi over 4. This one, the denominator is 3, so we have 0, and then 3 pi over 3, and then times 2 would be 6. Same thing for this one, 3 pi over 3, multiply it by 2, you get 6. And then pi, that one doesn't have a denominator. If you want to, you can add a 1, and you can make this 1 pi over 1. Oops. 1 pi over 1, and then 2 pi. But you don't really need the 1 over 1, because that's not going to make a difference. So I can just leave it as pi and 2 pi. Okay. Now, let's try to figure out where the numerator is located. So right here we have 7. Okay. I have 6 here, so I know that 7 is going to have to be 1 more. So this is going to be quadrant 3. On this one, I want to find 7. I have 8 right here. So it's going to be 1 before So it has to be in quadrant 4. If I want to find 5, I have 6 here, so it has to be one right before that. So this one is also in quadrant 4. If I want to find 2, that has to be one before 3. So this one is in quadrant 2 because we would have 0, 1, 2, and then 3. So 2 would be right here in quadrant 2. And then pi, which is right here, that's going to be the x-axis. And if you remember this coordinate point, if you go to the left one, that'll be -1, 0. Okay, now that we have the quadrant numbers, we can go and assign positive or negative values. Let's skip the top one, the axes ones, and then let's keep going. Sine in quadrant 3 is negative. Cosine in quadrant 4 is positive. Cosine in quadrant 2 is negative. Sine in quadrant 3 is negative. Cosine in quadrant 3 is negative. Sine in quadrant 4 is negative. Tangent in quadrant 4 is negative. Tangent in quadrant 2 is negative. And we'll skip the one on the axis. All right, so for the one on the axis, again, we have sine and we have, oops, I wrote that backwards. We have cosine as x, sine as y. So if they want cosine, you just have to give the value right there, which would be 0. Okay. For the other ones, what you're going to do is focus on the back part. So we got pi over 3, pi over 6, pi over 4, pi over 4, pi over 6, pi over 4, pi over 3, pi over 3. So you only are going to do the part that's in the blue bubble because your hand trick only goes from 0 pi, pi over 6, pi over 4, pi over 3, and then pi over 2. So you can't have a numerator. The only thing the numerator is there for is to tell you the quadrant number. But after you know the quadrant, that first number is irrelevant. So don't even worry about it. So all we're going to do here is sine of pi over 3. So your pi over 3 finger, which is your index finger, and then you have the fingers at the bottom for sine, so you got the square root of 3 divided by 2. Okay, for cosine, we have cosine of pi over 6. Your pi over 6 finger is your ring finger. Cosine is fingers on the top, so we got the square root of 3 divided by 2. Cosine of pi over 4 is square root of 2 divided by 2. Sine of pi over 4 is the same thing, square root of 2 divided by 2. So that's one column. Now let's try the next one. We have cosine of pi over 6. Fold your pi over 6 finger, which is your ring finger. I have 3 fingers above my ring finger for cosine, so negative square root of 3 divided by 2. For sine of pi over 4, you got square root of 2 divided by 2. Tangent of pi over 3. Your pi over 3 finger is your pointer finger. Tangent is square root of the bottom. I have 3 fingers at the bottom divided by the square root of the top, which is 1. This simplifies to negative square root of 3 over 1, or just simply the negative square root of 3. Okay. Tangent of pi over 3. That's going to be the same thing as before. Square root of 3 divided by square root of 1, which is just negative square root of 3. Now for the tangent one, on your formula chart, you have that under the quotient identities, we know that tangent theta is sine theta divided by cosine theta. So if I want tangent and I have over here cosine and sine, then I can take those values and put them over here. So sine is 0 and cosine is -1. Okay, this equals 0. 0 on the top is just 0. Okay, let me just make sure those are correct. All right, everything is perfect. Let's go on to the next page. So far we've only done sine, cosine, and tangent. We have not done the reciprocals yet, so we're going to do the reciprocals in all 4 quadrants. The steps are going to be the same. You're going to find the quadrant that you're at. If you need to find the reference angle, you'll do that. And basically, you'll find the original answer, and then the reciprocal is when you just flip the fraction. So we'll find the original and then flip it. Okay, so I'm going to first figure out what quadrant all of these are located in. So 45 degrees is in quadrant 1, 225 is in quadrant 3, 300 is in quadrant 4, 120 is in quadrant 2, 90 degrees is on the y-axis, 315 is in quadrant 4, and 150 is in quadrant 2. Okay, I'm going to do a column for the reference angle. So these, I'm gonna use the same formulas from the second page. So depending on the quadrant, you'll do something different. So if you're in quadrant 1, it stays the same. Quadrant 2, 180 minus the angle. Quadrant 3, the angle minus 180. And quadrant 4, 360 minus the angle. Okay, so in quadrant 1, they're gonna stay the same. So we have 45 degrees. In quadrant 3, that's 225 minus 180, which is 45 degrees. Quadrant 4 is 360 minus 300, so you have 60 degrees. Quadrant 2 is 180 minus 120, 60 degrees. The y-axis, you can have a reference angle of 90 degrees. Your reference angles are between 0 and 90, okay? And 315, that's 360 minus 315 is 45 degrees. 150 in quadrant 2, so that's 180 minus 150 is 30 degrees. Okay, so now we can assign positive or negative values. So or first we can figure out what the originals are going to be. That might help you guys since you're more familiar with sine, cosine, and tangent as opposed to the reciprocals. I'm making a little separation here because I'm going to use this space to write the original trig functions. Okay, so the reciprocal of secant is cosine. For the reciprocal, you're going to use the reference angle, which is 45 degrees. So I'm going to do cosine of 45. Okay, for the next one, the reciprocal of cosecant is sine, and the reference angle is 45. For the next one, the reciprocal of secant is cosine, the reference angle is 60. The reciprocal of cotangent is tangent, the reference angle is 60. The next one, cosecant, that would be sine, the reference angle is 90. Cotangent, reciprocal is tangent, and the reference angle is 45. And then we have secant, which is cosine, the reference angle is 30. Okay, so now you can kind of figure it out. So quadrant 1 cosine, that's positive. Quadrant 3 sine, that's going to be negative. Quadrant 4 cosine is positive. Quadrant 2 tangent, that's negative. We'll skip the y-axis one. Quadrant 4 tangent, that's negative. And quadrant 2 cosine, also negative. Okay, so now we'll do the hand trick with the original ones, and then we'll just take the reciprocal for the final answer. So fold your 45-degree finger, which is your middle finger. Cosine is the fingers at the top, so we have the square root of 2 divided by 2. If I flip that around, I get 2 over the square root of 2. I can't have a square root at the bottom, so I do have to rationalize this, which gives me 2 square root of 2 over 2. These 2's cancel out, so your final answer is just the square root of 2. Okay, sine of 45, you got the square root of 2 divided by 2. You flip that around, we get 2 square root of 2. And we did just do all of this work, so we know the final answer will be the same, except this time it's negative, the square root of 2. Cosine of 60, 60 degrees is your index finger. You got one finger up there, so that's square root of 1 divided by 2. You flip that around, you get 2 square root of 1. Well, the square root of 1 is just 1, and 2 divided by 1 is just 2. So the final answer is 2. Tangent of 60, you're going to fold your pointer finger. Tangent is bottom over top. Square root of 3 divided by the square root of 1. Flip that around, you get square root of 1 over the square root of 3. Rationalize it, you get negative square root of 3 over 3. Sine of 90, 90 degrees is your thumb. Sine is fingers at the bottom, so I have square root of 4 divided by 2. I flip that around, I get 2 divided by the square root of 4. 2 divided by 2 is 1. tangent of 45 would be the square root of 2 divided by the square root of 2. Flip it around, you're still going to get square root of 2 divided by square root of 2, and anything divided by itself is always 1, but this answer was negative. And then cosine of 30, you're going to fold your ring finger. We got 3 fingers above my ring finger, so I have the square root of 3 divided by 2. And if I flip that around, I get 2 over square root of 3, which I have to rationalize. Carry your negative, we get 2 square root of 3 divided by 3. Okay, so there we have the degree side. Now we're going to try to do this in radians. So with the radians, you don't need the reference angle, but you do need to figure out what quadrant you're in. So I'm going to make a little column for quadrant number. And that's where we're going to draw our little miniature unit circles. Okay. How many do I need? I have 1, 2, 3, 4, 5, 6. And just copy and paste this. I think it'll be faster. Okay, so for the first one, I have a denominator of 6. Well, all of these are going to start at 0. So we have 0, 0, 0, 0, 0, and 0. Okay, on the other side, that's where you match the denominator. So this time, I'm going to have 6 pi over 6. This is 3 pi over 3. This one would be 4 pi over 4. This one is 6 pi over 6. So whatever the denominator is, just match it, okay? 3 pi over 3. And this one is 4. So 4 pi over 4. Now for the other side, that's when you multiply it by 2. So 6 times 2 is 12. 3 times 2 is 6. 4 times 2 is 8. 6 times 2 is 12. 3 times 2 is 6. 4 times 2 is 8. Okay, now we're going to try to figure out where the numerator is at. So the numerator is 11. Where do I see 11? Well, I have 12 right here. So one below that will be 11. So this one has to be in quadrant 4. Okay. Now the next one is pi. Well, what's the coefficient of something if there's no number? It has to be 1. So this is 1 pi. Well, if this is 0, that means the next one would have to be 1. So 1 would actually be in quadrant 1. Okay. Where would I find 3? We have 4 here, so it has to be 1 before, which would be in quadrant 2. 7, we have 6 here, and 7 is 1 more, so that would have to be in quadrant 3. 5, we have 6 right here. So this is 6, so 5 would be right before you get to 6. So this is in quadrant 4. And then again, there's no coefficient, so it has to be 1 pi, and that would be right after 0. So you go 0 and then 1. So this is in quadrant 1. Okay. Now for the positives and negatives. Let's figure out what the reciprocals are. So let's do the originals. So the reciprocal of secant is cosine. Reciprocal of cotangent is tangent. Cosecant is sine. Cosecant is sine. Secant is cosine. And cotangent is tangent. Now, what are the angles going to be? The angles are the fraction on the back, remember? So you ignore the numerator and you're only going to do pi over 6, pi over 3, pi over 4, pi over 6, pi over 3, and pi over 4. So basically ignore the numerator. We've already used it. We don't need it anymore. So when you do the originals, you're going to do cosine of pi over 6, pi over 3, pi over 4, pi over 6, pi over 3, and pi over 4. And now you're going to use your hand trick to get the answers, and then we're going to flip them around to get the reciprocals. Okay, so cosine of pi over 6. Oh wait, we haven't done positives or negatives. Hold on. Okay, quadrant 4 cosine is positive. Quadrant 1 tangent, positive. Quadrant 2 sine, positive. Quadrant 3 sine, that one is going to be negative. Quadrant 4 cosine, positive. And in quadrant 1 tangent, that's positive. So we only had one of them that were negative. Okay, cosine of pi over 6. Your pi over 6 finger is your ring finger. Cosine is top, so we got the square root of 3 divided by 2. If I flip that around, we get 2 over the square root of 3. You have to rationalize it. You end up with 2 square root of 3 over 3. Okay, the next one is tangent of pi over 3, which is your pointer finger. Tangent is the square root of the bottom divided by the square root of the top. You flip that around, and then you have to rationalize it. You end up with the square root of 3 divided by 3. Sine of pi over 4, that's your middle finger. Number of fingers at the bottom is 2. Flip that around, 2 over the square root of 2. Rationalize it, you get 2 square root of 2 divided by 2, which these cancel. Final answer would be just the square root of 2. Sine of pi over 6, you're going to fold your ring finger. You got one finger down there. You got square root of 1 over 2. Flip it around. The square root of 1 is just 1. And negative 2 divided by 1 is just negative 2. Cosine of pi over 3, you're going to fold over your index finger. And cosine is fingers at the top, so that's square root of 1 over 2. You flip that around, you get 2 square root of 1, which is 2 over 1, or just positive 2. And then tangent of pi over 4, that would be the square root of 2 divided by the square root of 2. You flip that around, you end up with the same thing. Anything divided by itself is 1. Okay, so that's how you do the reciprocals in radians. Now the last thing I need to show you is how to evaluate negative angles. So it's basically the same process, just that the coordinate plane, instead of going up, we're going to be going down. So down here in the corner, I'm going to draw a new coordinate plane for you. So we still have 0 degrees here, but this time we're going down, okay? So I'm going to go negative 90 degrees, and then I'm going to keep going this way. I'm going to end up at negative 180 degrees. If I keep going, I'm going to end up at negative 270 degrees. And if I keep going, I'll end up at negative 360. So notice that this time we're going clockwise versus the other way. So basically we're going down, okay? We can also do this in radians. So 0 degrees is 0 radians. Negative 90 would be negative pi over 2. Negative 180 is negative pi. Negative 270 is negative 3 pi over 2. And then negative 360, which is negative 2 pi. Okay, now in terms of your quadrants, those are not going to change. This is still quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And when you do all students take calculus, that doesn't change either. Okay, so the only thing that changes is where the negative angle will be located. Now, to find the reference angle, that's also going to be a little bit different than what we practiced earlier on the second page. So since we're dealing with negative angles, we're going to have to take the absolute value of the angles. And remember, the absolute value, all that does is make the number positive. So it's kind of like you're just going to disregard the negative and pretend it's not there. Okay, so for all of these, I'm going to do the reference angle equals. Reference angle equals. In quadrant 1, the reference angle will be 360 minus the absolute value of the angle that they give you in the question. In quadrant 2, it's the absolute value of the given angle minus 180. In quadrant 3, it's 180 minus the absolute value of the angle they give you. And in quadrant 4, the reference angle is just the absolute value of the angle that's given to you. Okay, so let's find the reference angles on these negative angles. So the first thing we need to figure out is what quadrants are they in. So negative 60, notice that this is now 0 and 90. So negative 60 would be down here in quadrant 4. Negative 330 would now be between 270 and 360, somewhere right here in quadrant 1. Negative 135 would now be between 180 and 90, so 135 would be somewhere here in quadrant 3. Negative 270 is right here on the y-axis. Negative 120, again in quadrant 3. Tangent of negative 30 would be in quadrant 4. And since I forgot to add one in quadrant 2, I'm going to just write it in here. We're going to do sine of negative 240, just so that we can practice one in quadrant 2. Okay. So now let's find the reference angles. So in quadrant 4, your reference angle is the absolute value of the angle. So the absolute value of negative 60 is just 60 degrees. In quadrant 1, you do 360 minus the absolute value of 330. So 360 minus 330, which is 30 degrees. In quadrant 3, you're going to do 180 minus the angle. So 180 minus 135, which is 45 degrees. Negative 270. So if you notice, negative 270 is right here, which is on the y-axis. But if we think about this as a positive value, this is actually positive 90 degrees, right? So the reference angle would be 90 degrees. So your reference angles can be between 0 and 90, but they can't go past 90. So 90 is still a good acceptable answer for that, okay? Negative 120, you're going to have a reference angle of 60 degrees. The negative 30, you take the absolute value, you get 30. And then you get 240 minus 180 is 60 degrees. So those are going to be our reference angles. Now, if I have to, I'm going to write a column for the originals. I might not have to use them if they already give me the originals, okay? Let's see which ones are the reciprocals. Sine is good. Cotangent, we have tangent. Cosecant is sine. Secant is cosine. And then the others are all originals, okay? Let's think about sines here. So quadrant 4 sine is going to be negative. Quadrant 1 tangent is positive. Quadrant 3 sine is negative. The y-axis will skip that one. Quadrant 3 cosine, that's negative. Quadrant 4 tangent is negative, and quadrant 2 sine is positive. All right, so we're going to do sine of the reference angle. So sine of 60, fold your 60-degree finger, which is your index finger. Square root of 3 divided by 2, because we're looking at sine, which is fingers at the bottom. So negative square root of 3 divided by 2. Next one, we got cotangent, but we know the reciprocal is tangent, and I'm going to use the reference angle. So I'm going to do tangent of 30 degrees. 30 degrees is your ring finger. Tangent is the square root of the bottom divided by the square root of the top. If I flip this around for the reciprocal, the square root of 1 is 1, and this just simplifies to the square root of 3. Okay. Next up, we're going to do sine of the reference angle, which is 45. So I'm going to just move that over here. Sine of 45 is the square root of 2 divided by 2. You flip that around, you get 2 square root of 2. You have to rationalize it, and you get negative 2 square root of 2 over 2. The 2's cancel out, and you end up with negative square root of 2. Next up, we have cosine of 90 degrees. Your 90-degree finger is your thumb. There are no fingers above that, so that's square root of 2 divided by 2. You flip it around, you got 2 square root of 0, which is just 2 over 0, and you cannot divide by 0 at the bottom, so this one is undefined. Then we have cosine of 60. So remember, you're just using the reference angles. Cosine of 60 is the square root of 1 divided by 2, which simplifies to negative 1/2. Tangent of 30, square root of 1 divided by the square root of 3. You gotta rationalize this. You get negative square root of 3 divided by 3. And then the last one, sine of 60, you got square root of 3 divided by 2. Okay. Just double check these are all correct. And they are. Okay, we're almost done. Let's just do this again in radians. So the little circles we did earlier, we're gonna do those again. How many do I have? 1, 2. Well, let me just do one at a time. Alright, so for the first one, you draw your circle, you draw your x-axis. We're at 0 degrees. But now instead of going up, we're gonna go down because this is a negative angle. And then you match your denominator. So we're gonna have, and these are negative, so it'll be this time negative. What is all this that came up? I'm sorry. I think my thing lags sometimes. Negative 3 pi over 3. And then if you keep going around, you're going to end up times 2, which is negative 6 pi over 3. So now you want to figure out where is negative 2 going to be. Well, this is 0. And instead of going up like we were before, this time we're going down. So if this is 0, this would be negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. Okay? So negative 2 will be 1 before you get to negative 3. So this one is in quadrant 3. Okay, let's try that again. We have a circle. We're starting at 0. Instead of going up, we're going down because it's negative. This denominator is 4, so I'm going to have negative 4 pi over 4. Multiply that by 2, we get negative 8 pi over 4. So where is negative 5? Negative 5 would be 1 after negative 4, which is in quadrant 2. So again, we have 0, negative 1, negative 2, negative 3, negative 4, and then negative 5. Okay, because we're counting down this time. Negative pi is on the x-axis. Negative 3 pi over 2 is on the y-axis. So if you look here, negative pi is right here on the x-axis. Negative 3 pi over 2 is right here on the y-axis. Okay, and then negative 5 pi over 4, we just did it, so I already know that's in quadrant 2. Okay, so now let's talk about signs. Sine in quadrant 3 is negative. Cosine in quadrant 2 is negative. The coordinate point for negative pi is negative 1, 0, because you're going 1 unit to the left. For negative 3 pi over 2, notice that this one is up here, so we went 1 unit up. So this one is 0, 1. And then quadrant 2 tangent is negative. Okay. Now for the hand trick, you only do the fraction in the back, so we're only doing pi over 3, pi over 4, etc. pi over 4 for the last one. Okay, so sine of pi over 3, your pi over 3 finger is your pointer finger, sine is fingers at the bottom. I have 3 fingers, so square root of 3 divided by 2, and we know that it is negative. For cosine of pi over 4, you fold your middle finger, you got square root of 2 divided by 2, also negative. For the ones on the axes, remember that you have cosine as x, sine as y. So if they only want cosine, you only have to give the x coordinate, which is negative 1. And same thing for the next one. If they only want sine, you only have to give the y coordinate, which is positive 1. And then tangent of pi over 4, fold your middle finger, you got square root of 2 divided by the square root of 2, which simplifies to negative 1. Okay, and these are all of the notes and all the examples I have for today. Let me know if you have any questions, and I hope you learned something today. Bye.